All right. We are on. Okay. Let's move this aside. Unfortunately, I will need my phone to look at the questions. Oh, well. Okay. It's odd that they've done this in kind of a reverse order. Interesting choices. Okay. How do we look? Okay, based on these types of questions, we would have to go through the idea of function. Idea of functions. We're going to have to go through the idea of a function. So this will be single variable calculus. Be doing like f of x. And we'll be g of x or f of p or f of p plus h. F of a number like 3, etc. Doing functions. Now, how would I want to do this off the top of my head? Okay. So I'm going to make a space. I know this sounds weird, but this is our x. This is our input. And this here is our y, or our f of x. And this is our output. So what happens is we take our x's, apply the operation. Oh, hello there, Steve Jobs. And it will give us our output. I've got a student that is wanting to go through some pre-calculus stuff, and I'm just waiting for her to join. So what's new with you, Mr. Steve Jobs? Oh, brilliant. Won't be doing electrostatic yet. I'm waiting on another student that we had organized and planned for this morning. And I still have to look up the electrostatic. You've given me the topics, but I have to look them up. Integration application. Uh, okay, okay. Well, I'm just trying to get the student in that arranged for it. I'll be um I'll be looking up your topics there afterwards and see what I can find and help you out with. We were doing some pre-calc. And she's coming. I think she's just a little lost. I don't know why, but YouTube Live seems to be pretty difficult to find for some reason. I've had multiple times where I just say go to the channel and click on the video, and it's difficult to find. Yeah, notifications as well are pretty slow. I've had notifications come up like hours after for some reason. I don't get it. Okay. Well, I'm waiting. I'm gonna grab my book. Mostly just want topics. Oh, the video's unavailable. There is Lisa, that's you? Is it working now? There you go. I don't know why you had an unavailable video for a while there. It's the first time I've seen a unavailable video. I'm not certain. Like, are you receiving this really quickly? Like, just gonna type in chat to confirm. Interesting. Interesting. Hmm. Not sure what to do in that case. It's weird that we've had such difficulty. Oh, it's unfortunate. Well, the link is for my Discord server. In the Discord server is where we can meet up and we can have calls, and is where I post a lot of the stuff that I make, so that even when we do, like, so right now we're doing these functions and stuff, right? I can save all these images and I'll post them in the Discord server so that you can print them off or just have them copied. Yep, we'll be going through it. I'm just trying to get in connection here with the student, and we're going to go through a bunch of functions and algebra type stuff. Uh, Lisa here can't see the stream, and that's what we're trying to get sorted out. Would have been easier just to have it work straight away, but just working through it. No big deal. We're coming. We're coming. There you are. Okay. Can you see this now? Is my mic? Yeah, my mic's still picking up. Um, if you turn your mic on, yes, I would be able to hear you. You would be able to talk to me just like a call, but I have my screen share. So I believe you just turned your mic on. If you speak, it should come through, unless you just have some settings issues you can change. That's okay. If your mic's not working, that's fine. You can just type in chat. Okay. So now that we've got everything back to normal and kind of working, we're going to go through your functions and we're going to start talking about it. If the screen starts kind of glitching, don't worry about it too much. I'm just going to kind of turn it off and on. Okay. So based on the problems that you had given me, I kind of want to go through like functions. So you'll let me know if anything is kind of far away or if you don't understand, and we'll just kind of go through it. So while I was waiting, I drew up this little diagram here. So with functions, we're going to talk about just kind of like the input and the output and understanding like which part is which and which one's the domain and which is the range and all those type things. So normally you'll see a function like y equals some function of x. That's why we'll say y equals f of x. Yeah, no worries, you let me know. If you click on my little box, you should see my screen. I have my screen share up. Oh, here, I'll send you a quick little picture. See? There's a little box with my name or just my picture and my mic on the side there. Click on that, you should be able to see my screen. And let me know when you do. Either that or you can just stay on call and watch the stream, just have it muted. So I sent you a picture on Instagram. You can see at the top right hand corner, there's those two little images. Steve, if you want to join the server, you just click on that link there and it'll join the Discord server. So the green box is yours, and then the other one would be me, and you would just click on that one. So Steve, we're in a private call right now, so that's joining the server is great, and you'll just be there for later. Okay, no worries. Just don't worry about the call so much. Just keep the stream up, and I'll just talk to you. Oh wait, you can't see the stream. So there's two boxes at the top right. The green one is you. The other one is me. See those two boxes? Or they'll be in the center or anything of that nature. All you need to do is click on the box that says brains and you should be able to see my screen. That's just the server, Steve. That's where it's kind of like a meeting ground. So Steve, if you wanted to take a few pictures of some stuff that you're working on or ask questions, you can go ahead and ask them in the text channels, like the post question channel. You can go ahead and write them in there. Here, I'll stop sharing the screen and I'll turn it back on again and see if you comes up more. Is either working for you yet there? Oh, there seems to be an issue. Oh, you haven't finished your connection. You see at the bottom left there, got that exclamation point? You have to finish your account verification. Most likely. So at the bottom left, it has that video connected and it has that exclamation point. Might want to just check and see what that is. If your internet is having such an issue, which hopefully it wouldn't, because that would be really unfortunate. Because if you can watch YouTube, you should be able to watch this fine. Just double check. Sorry, like this shouldn't be you. And YouTube's not working for you. Yeah, sure, no worries. I'll just continue and you can come on back. Just let me know when you're back. Okay. So we will carry on with functions later. Buddy here wants to look at a few. So let's take a look. Now I have to do a little bit of research, so this is boring the part. Yeah, I don't think I would be able to do this in like 30 seconds to look things up. I need to spend a little bit of time actually looking up this stuff. So I'm just going to save it for off stream. So until then, we're going to get prepared with the other thing. So let's get some topics in. Now, since it's going to be about half an hour, let's see what we can come up with. Probably going to need to go through a little bit of absolute value. Probably going to have to go with a little bit on radicals. Yeah, Steve, I'd have to look it up. Like, I can't just look it up in 30 seconds and know everything about it. I'm gonna have to do it off stream and, like, come back to you on a bunch of them. Like, I don't have notes or a textbook on it, so I actually, like, have to spend time looking them up. If you wanted to do, like, actual more math stuff, yeah, let's do it. In terms of, like, chemistry and physics stuff at the moment, I have to spend time to actually look them up. Division of fractions, maybe? Double check trig. One moment. Okay. Probably trig. Maybe just a quick identity. Just like a review thing. Rest don't matter. We'll have to do linear equations at one point. That's good. Domain range functions. Input and output. She's not going to do transformations yet. I think that's really about it. That's a good start. Yeah, that's about it. Double check what other topics were included and then see what we think. Mostly just input and output to begin with. And maybe a little bit about fact. Looks like just a preliminary course. So let's make some stuff. Okay, inverse circular function. So you'd be talking about like inverse trig functions, or do you mean like here? So like inverse trig functions? Like sine inverse, cosine inverse, tan inverse. Yeah, okay. So let's let me do a couple things here. I'm gonna bring some stuff. One momentum. It look a little pretty for us here. Okay. This here is a sine. This is sine. Okay. Sine x, we can tell, goes from 1 oh, the layers. Goes from 1 to -1 as the range, right? So the range is like the domain of sine inverse and opposite. So let's see. Right, again, arc sine. Uh, okay. Okay, this will be a little bit better to see and visualize. So, sine inverse and sine x. Cosine and tangent, same type deal. They're inverses of each other. We know that if we have a number x and we multiply by its inverse, 1 over x, we get 1, right? Okay, that's a good start. But with sine x and sine, if we take the sine inverse of sine of x, we will get our x back, right? I have to double check. So with this, sine x here has a range of 1 to -1, but the domain of sine inverse goes from -1. -1 to, so range of sine is the domain of sine inverse. And domain of sine x is the range of an inverse. However, we're only going to go from one part, from negative pi over 2 to pi over 2. Because in this graph here, I just shifted it, but this is really just pi over 2. And negative pi over 2 is over there. So when we're looking at like a unit circle, for example, and we want to find, so, okay, sine of pi over 2 is 1, right? We know that that's a regular angle. Sine inverse of both sides leaves us with then that we have pi over 2 sine inverse of 1, which is common. So if we're thinking about doing the opposite, if we're given like an answer, so if I take another thing like 1/2, if I have like sine x equals 1/2, basically it's like asking what angle makes sine equal to 1/2. Well, let's think about it. Or you can just use your unit circle. That's what I usually do. Because memorizing things is not a thing I do often. So, what angle makes sine 1/2. By using the unit circle, we would see that pi over 6, sine of pi over 6 is 1/2. You don't know the unit circle. Okay, then we should go through that instead. That's a bit more handy. Sine of pi over 6 is 1/2, so that means x equals pi over 6. Okay, let's draw the unit circles because that would be a little bit more handy for it. Okay. Now, you've probably seen on my Instagram, I had a colorful post at one point. And let's... that for now. Perfect. So this here is the unit circle. The unit circle is what pretty much every student learns when it comes to trigonometry. The unit circle is the standard circle. If we were to graph x squared plus y squared equals to 1, this is what we would get. Example in Desmos. There. Yeah, the equation of a circle. X squared plus y squared is 1. Regular equation of a circle. So the radius of the circle is 1, right? So this, as you can see right here, this distance is 1. And everywhere else it's 1 as well. Right? Standard equation of a circle. Well, the unit circle has special angles that we can use. Because remember that sine, cos, and tan and all that stuff, they are ratios of side lengths of a triangle, right? If I quickly just kind of write down a few of them, like if I make a triangle like this, I can label this x, this y, and this r. R for hypotenuse. And this will be theta here. Sine of theta will be the ratio y over r. Cosine of theta is the ratio x over r. Tan of theta, ratio of y over x. Okay, that's just the standard 3. Then you can go into secant, cosecant, cotan, all that stuff. And those are just like 1 over these ratios. So with the unit circle, this nice colorful diagram here, it gives us the special angles that these ratios have an easy number to represent. So, for example, pi over 6, or 30 degrees if you use degrees, cosine has a simple answer of root 3 over 2. Cosine of pi over 6 is 2. Sine of pi over 6 is half. That's just like a simple answer to it. There aren't too many angles like this that have simple answers. Like these are just like easy to understand and represent. So like sine of pi over 6 equals 1/2. That's a simple number to write down, right? Unit circle has these triangles inherently in them. So if we make our triangles, this here is the pi over 6. This triangle has side lengths that we can use. This is a 30-degree triangle. This 30-degree triangle has side lengths of 1, 2, and root 3. So if we use our ratios, sine of theta, which will be y over r, which will be just 1 over 2. That's sine of 30 degrees. Cosine of 30 degrees, just like our ratio here, x over r, so root 3 over 2. Just like our unit circle. And then the unit circle is broken up into a few different angles. This triangle here is the special triangle with the 1, 2, and root 3. The other special triangle we use, which I probably won't draw properly, is the 1, 1, and root 2. I'll write it in here. This is a 45-degree triangle. So if we go back to our other one up here, this one will be like a 45-degree angle. That's where we're coming from. These triangles are the special angles. These special triangles, which are, like using the Pythagorean theorem, so x squared plus y squared equals r squared. If we set the side length of one of them to be 1, so like x and y are the same, both being 1, then r is 2. These are just the special triangles. One, 2, and root 3, and 1, 1, and root 2. That's just what they are. So once I'm done kind of like explaining about the unit circle, I can show you how to like draw it really easily. Then that's extremely useful on a test. because these are right triangles, so they have to satisfy that equation. Okay, so then we'll do this again. The sine of 45 degrees. Yeah. First thing I always tell people is don't memorize. It's a waste of time. You can create it. It's better than memorizing. Yeah, very difficult task to memorize. It's easier to remember two triangles than it is to memorize which one's root 3 over 2 and which one's negative 1/2. And like that just seems like a whole lot of confusion to me. But knowing a couple triangles and then just figuring them out is a lot simpler. Because you have to know these trig ratios anyways. You go through it a lot. Yeah. So we go into sine. Is y over r, so that would be 1 over root 2. And we normally like to rationalize, so that would just be root 2 over 2. Cosine 45 degrees. Again, root 2 over 2. Tan. Remember, tan is sine over cos. So if it's the same thing over the same thing, that's just 1. So that's where these values come from. This unit circle is where these values come from. Like I've seen lots of people try and memorize a chart. I find charts to be not as useful. Okay, let's take a look and see here. Okay, so that was the first two. The last one is interesting because it's actually the same as the first triangle. It's just changed the side lengths. And they're just swapped around. So actually, pi over 6 and pi over 3 have the same values. They're just in a different order. Swapped. So like, this was 30 degrees for pi over 6. This triangle had the root 3 over 2. Half. This was the 1, 1 root 2, or 45 degrees. Pi over 4. 2 over 2. And this one was root 2 over 2. This one is like 60 degrees. And that's pi over 3. And it just has the opposite order. So actually, it's going to be 1/2 and root 3 over 2. Oops, I wrote root. And then you just continue all the way around the unit circle. So this up here is pi over 2. Well, you can see even just by following the unit circle itself, that this here, this value is 0, 1. This value down here is 0, -1. This value over here, 1, 0. See the pattern and how it's going up? Like, this is a real graph. Okay. Let me know if you see it. Okay. I think the next thing to do in regards to just the unit circle here would just be a quick way to write it down to show it. These angles, like the pi over 2, the 2 pi over 3, 3 pi over 4, all that stuff, you can kind of like find your own way to remember them. I just like to kind of go across and be like, here's 0, here's pi, this is 1/4 pi, that's 3/4 pi, you know, and all the way around. Let's see. Don't worry, Lisa, I'm just gonna finish explaining. Working. Is YouTube working yet? Frame just die? Go drop frame. That's still there. Mic die. Oh, the mic's still there. Okay, good. Still good. So the next thing to do would be just kind of like how you would draw it quickly. And what I suggest you do is actually just take a look at that post I did on this. And there's a quick, detailed list of just like 3 simple steps. Kind of, right? 1, 2, 3, and 3, 2, 1. Divide everything by 2. Square root the top. You have your values. And the values are the same for everything that's connected. All you have to do is just change whatever sign it is. Because remember, this is just like a regular plotted diagram. Don't worry, Lisa, I'm here. It's just not working, eh? Yeah, you hear me, but you can't see the screen, and that's kind of makes it a difficult. So the YouTube video is not working. Like, she clicks on it, it loads, and then it just goes to like an ending screen. Now in Discord, I turned on the screen share, but you can't see that either, apparently, for some reason. It's possible that it's your settings, but I'm not sure what you would change. Images. Let's do a quick Google check. She did reboot. The other thing I would do is potentially run Discord in admin mode. It's possible. Like looking online for settings. No worries, we're gonna get it sorted out. Voice and video, just your settings. Video settings, video allow. I've got one idea. Here, this might work perfectly. Just hold on one quick second. I'm going to send you a friend request. There might be some kind of like finicky thing because you're a new user. So I sent you a friend request. If you go to your list, you should find friends, and in pending, you want to accept it from me. I'm gonna send you a quick picture. Well, it might just be finicky. It might be some random little thing. It may not actually be a real problem. It could be that your settings will be like you don't trust. You have it set so you don't trust me, which is a potential. So if I send you a friend request, it might work. Okay, good. Click on the video icon. You might just you should be able to still like click on me again. Might work better. Because if you now have a video icon, that's probably a good sign. We're working it through here. Give me a minute. So, Lisa, can you now click on me to see the screen? Like, what is it giving you? Hmm. Don't know why yours having such an issue. Might be something just simple. Yeah, the video is connected. It says everything's fine. Just not clicked on the. I'll turn off screen share and turn it back on. We'll see what comes up. And like, this is absurd. Like, for one, it's weird that the YouTube doesn't work because never had that before. I can understand like a call not working for some internets and whatnot, but the YouTube should be working just fine. I don't know why it's not working. Could be your location, even clicked on the video, but that doesn't make any sense. Even try your phone. If you can go onto YouTube on your phone, see if that works. Okay, Steve, what else is there about this unit circle we could go through? Um, that's pretty much it. You would just go through and like you would create it. You've got the steps. You can use either the triangles or you could even just like do the 1, 2, 3 and 3, 2, 1 thing like on my Instagram post. You know the ratios. Anything else would just be like trig identity. And doing an inverse is like, so yeah, going back to the inverse stuff would be like we already have a value, we just need the angle. Hmm. Oh. Or nothing. know what to tell you. Don't know. Ooh, Nilly. It's normally the easiest thing to come up with. Either the call will work or the YouTube video. You're in. So can you see everything now? Can you see my unit circle? Can you hear me? Yeah. I don't know why it was not working for you. That's the most absurd thing I've ever seen. Okay. Now we can go through. Okay. Great, great, great. Okay. I'm just gonna quickly do a little cleanup on my own end here. 1 second. There. Okay. Okay, Lisa. So we were going to go through your functions. Steve, just relax, man. This was our functions idea. So we needed to discuss how functions kind of work, because you've got a little bit about domain, a little bit about range, and you're probably going to have to do substitution, plugging them in, and operating with them. So we've got like a function f of x. Well, we could also say y equals f of x. And we could also have like g of x or h of x, or we could even have a function of x plus h, or f of 3, or f of t squared plus t plus 1, you know, anything like that. These are all just kind of like functions and inputs. So just kind of like a basic understanding of function. If I have a kind of a space of numbers, I know this is weird, it looks weird. This is just like all our numbers. Could be the real numbers, could be anything. This is just all our numbers, and we're gonna call that x. This is like our input. Okay? Our function, so let's say f of x, is like our output. Okay? And an output is like some kind of operation. So like this would be, here's our value x1, here's our value that we get from it when we have that operation, f of x1. So then we would have like another value, 2. This would be like f of x2. This is considered our domain. These are like our input. This is our range. This is our output. And we can have different types of numbers, different types of inputs, etc. So let's do a couple examples of kind of like changing a function, doing this f of x, g of x, all that stuff. So I'm going to have a function f of x, and I'm going to call it x plus 1. So this is our operation. This is what happens. X is the input. X plus 1 is the output. So whatever you have as your input, it changes to just like add 1 to it. Now, if we change our input to be something else, so like f of 3, well, that's pretty simple because now our input is 3. So everywhere that we would have seen an x, we now see a 3. 1, f of 3 is not a big deal. We can change that as well to be anything else we want. So like f of x plus some number h. Okay? All we did was change our input from just being x to being some number x plus h. So let's change that in our function. X is what we had originally, so now we're going to change the x to x plus h. And I'm going to write it in parentheses, even though I don't need them, because it symbolizes what we're changing. And that's still plus 1. So if we just remove it, it would just become x plus h plus 1. Not a big deal. If I had another function, like let's say g, and this is x squared plus x plus 1. A little bit more complicated, but it's fine. We can still do similar things. This will be, what's g of 3? Let's do a small. G of 1. Now we're going to take 1 and replace it for x in each of our in our function. So this would become 1. I'm going to write it in parentheses squared plus 1, 1. So 1 squared is 1. 1 plus 1 plus 1 is 3. The reason why I wanted to do it this one is because there's another thing as well when we plug in a negative number. So like g of negative 1. This is where students usually will mess up. They will write negative 1 squared. And then they'll just square the 1 and they'll leave the 1. That's wrong. You need to actually make sure that whatever the operation is acting on it, acts on whenever you're plugging in. So when we plug in the negative 1, it will have to be squared itself. Plus negative 1 plus 1. Well, this is 1 because negative 1 squared is negative 1 times negative 1, so that's a positive. This is minus 1. This is plus 1. We get 1 this time. We can also put a function in for a variable. So I'm going to say, what is g of f of x? Yeah, exactly. this is the same as what we were doing before, but now instead of x, our input is f of x. Well, our f of x is x plus 1, and our g of x is x squared plus x plus 1. So we're going to write g of x, but instead of an x, we're going to write whatever f of x. So I'm going to write it out in 2 lines, even though you don't need to. So this would be like f of x squared plus f of x plus 1. But f of x is x plus 1. That would be x plus 1 squared plus x plus 1, 1. And then you just boil it out, you combine like terms, and you're good. Now the question I would have for you is, how comfortable are you with like multiplication, boiling it out? Pretty comfortable? Okay. So then when I FOIL this out, I would say this is x squared plus 2x plus 1 plus x plus 1 plus 1. This would be then x squared. 2x plus x is 3x. 1 plus 1 plus 1 is plus 3. So the only thing I would caution you is your squares here, because you need to remember that it is like a FOIL. So that would be like first times first, first times second, second times first, second times last. So just in case, x squared plus ax plus ax a squared. So then you'd have 2 of them, so x squared 2x. Just as like a cautionary. Okay. Let's double check. So in question 3, now that we've kind of gone through like inputs and outputs and all that stuff, we're going to go through question 3 that you sent me. We have 2 functions, but they're not like really big functions. They're not in like terms of variables. They're just kind of like, here's the plotted point. So we have f is equal to the plotted point of 1, 2, 3, 5, and 4, 7. And g is equal to the plotted point of 1, 4, and 3, 0, 5 comma 2. We want to do something with these points. So I'm gonna start with something simple. We've got a function y equals x. We've got another function y equals x. I know they're the same, but we're gonna have these two functions. y1 and y2. y1 plus y2 is 2x. Okay? I'm gonna make some kind of coordinate point. This is all just like kind of an example to kind of get you thinking about that. Here's x and here's y. So 1 and 1, 2 and 2, 3 and 3, etc. Right? If we now have 2x, here's x as our input, and now y is 2x. So this will be y1 plus 2, which will be 2x. When we have x is 1, we now have 2. When x is 2, we now have 4. When x is 3, we now have 6. Okay? So when we add the two together, it's actually just the output that's really changing, because the input is still the same. You still plug in 1. To get our input, and we then get our output of whatever the change is. So if we have two functions, our input's not going to change between the two of them. But our output will. Let's see. Any other thing I could do? Maybe like a graph? Yeah, I'll do a quick graph. So if we have a point 1 comma 2 in here, and oh, I should a bit bigger. So if we have a point, here's 1, 2, 0.1 comma 2. And we have another point, 1 comma 4. So the 2 and the 4 is the output. Four is an output. Okay, so the inputs of our functions is 1 and 3 and 4 for f and 5 for g. So the input will stay the same. It's the outputs that get added together. So if we have f plus g, we would actually leave the 1 the same, and we would just go, well, 2 plus 4, 6. We would use that for all the rest of our points. This is just like two sets of points added together. Since the input is the same for x equals 1, x equals 3, you can just actually sum the y values. If they are not the same, then you wouldn't add the y value. They would be completely different points. Now, I'm saying it this way because they say it's a function. If they were saying they were just sets of points, then you would just add up all. All right, good night, bud. Yeah, it's late at night where you are. How are you doing so far there, Lisa? Yeah, as long as they have the same input. Like, the only thing that's kind of finicky about like this type of question is just the kind of the way it's represented. Because if you were talking about statistics, something along those lines, since these are all different type of points, then they would like you would just add the two sets together. But we're not talking about that. We're talking about function. Well, I'm trying to make it as like close to functionally as possible. So f divided by g is another question. Now, f divided by g has some kind of iffy things to it. The first point works just fine. The second point, doesn't work so good. And then the third, and I guess fourth point, doesn't have a value, so they don't really work. So I'm not entirely sure what your class is expecting of you for this question. But to be fair, like you are going through like all the standard algebra stuff that you would be learning for pre-calc. The only thing is just because it's not like a high school course, that it's like more of a university course type, there is going to be a bit of a few weird topics included. Like, but it's not bad. It's not bad at all. Anyways, let's keep going. So for this question 3, do you understand about the inputs and the outputs and like what is a function and all that type of stuff? Or are you a little bit unclear? Because we'll be doing question 2 next, and it's relative to what we did in the past already. Okay. Then let's move on to your next type problem. Now this one I'm basically just gonna kind of do because there's not too much to it, but I can give you a little bit of extra. So in answer form for this, you would write kind of like f plus g, and then that you would equal, you would write your curly brackets and you would write your set of numbers. So this first one would be 1 comma 6. Then you would write your next one and then your next one and your next one. And then for this you'd write like f divided by g, write your set, the next one, the next one, the next one. I'll let you do that for a second. I'll be right back. I'm just gonna use the washroom. Okay. Next, we're going to talk about kind of like the idea of calculus, and the thing that you'll see a lot is this x plus h, or in your case, the t plus h. We're going to be given some kind of function. So I'm going to say f of x is x squared minus x. Okay, and then we're gonna write this function in a different way. We're gonna write it as f of x plus h, and we're gonna have a subtraction of f of x itself all over h. Now this is a very common thing to see, this difference quotient. All we have to do is literally just kind of write it as it's written. What is f of x plus h? And then subtract f of x and divide by h and simplify. So here we have f of x plus h. Well, we're just gonna, like we were doing before, we're just gonna replace our input x with x plus h. And x plus h squared minus x plus h, all in parentheses. What's our f of x? It's x squared x, so we can leave that as is. We're going to rewrite it now. F of x plus h is this. X plus h squared minus x plus h. Then we're going to subtract, and I'm going to write it in a big parenthesis because we're subtracting the whole function itself, not just the first term. Got x squared minus x in the big parenthesis. Then this whole thing is divided. Are you good so far? I feel like your delay is a little bit more than normal for some. Okay, good. Then all we have to do is simplify this. Well, x plus h squared is x squared plus 2xh plus h. I'm going to distribute this negative, so minus x minus h. Distribute this negative, so we've got negative x squared plus x all over h. Now, easy as it comes, we just gotta simplify. We've got this x squared, that's a minus, and this x squared, so they'll cancel out. Cross, cross. We've got this minus x and this plus x. Cross those out. So we're then left with 2xh. I'm going to write the minus h plus h squared all over 8. Then, typically what you'll do is you'll divide the h all the way through. So we're going to divide h but on to each term. So this will be 2x. H divided by h is just 1, so we'll just leave it as 2x. And then we'll have a minus h divided by h is a 1, so we'll have a minus 1. And then we'll have plus h. H squared divided by h. One of them cancels out, so we'll just have an h. And this is what we'll get as our final. I won't go too far from here. You tell me from here. Cool. This is a very common thing that you will go through. The only thing that's new is we're going to add a limit to it, but we're not there yet. That's actually in calculus. But if you can do this, then that question 2, super easy. So let's go ahead and do it. So let's see, what did we have for question 2? Something with t squared. So for your question, we had f of t equals 2t minus t. And again, we're going to do that difference. What's f of t plus h minus f of t over h? Now, this is the same thing as what we did in that last question. Now we just have to make sure we keep track of where we plug our t and our t plus h. Only thing I would caution you is try not to skip too many steps, because students always make mistakes when they skip many steps. What I like to do for new students is I like to write out each function first before I do the difference. So we need t plus h. So we've still got a 2 here, so we're going to write 2 in front. Instead of t, we're going to write t plus h. And then we're going to subtract, because there's still a subtraction here. And then instead of a t, we're going to have t plus h. T plus h. And that whole thing is squared. From here, you can simplify if you'd like. Wouldn't be a bad idea. So we would have 2 times t, 2t, 2 times h, so plus 2h. I'm going to write one extra line and just keep this negative in front for now. T squared plus 2, I'm going to say ht plus h squared. I'm going to distribute that negative, so 2t plus 2h minus t minus 2ht minus h squared. Okay, so this is just the f of t plus h. We haven't done anything, just plugged in t plus h in for t in our original. Pretty good so far. From here, I'd like you to tell me what's next. I know the delay's a little long, but we could kind of work through it a little slow. So what are we going to do next? Besides the fact that we're going to put it in this original form up here. I'll do this, and you'll tell me the simplification. So if I write the t plus h function, we have 2t plus 2h minus t squared minus 2ht minus h squared minus a 2t minus t squared. all over h. What will this simplify down? What are you going to do first? E plus 2. Well, I'm gonna distribute the negative first, and we'll go from there. 2t plus 2h minus t squared minus 2ht minus h squared minus 2t plus t squared all over 8. Okay. So I think you're on the right track. I'm just not sure about typing. Okay. So then what we see here, because in the top we can combine like terms, right? So I see this 2t and this minus 2t. They're the same. Let's cross them out. Then I see this t squared that's a minus, and this t squared that's a plus. So they're the same. We can cross them out. Then this is what we're left with. There's nothing else that really cancels. So we've got a 2h minus 2ht minus h squared all over h. Ah, that's okay. Parentheses, you'll figure it out really quick. You just got to remember that once you have a number in front, even if it's just like a minus sign, you got to take it onto each individual term. What we can do after this is just like a quick thing on like factoring and multiplication, just to make sure you. Now we're gonna split up and have each term divided by h. So like this would be 2h divided by h minus 2ht by h minus h squared divided by h. So these two h's will cancel out. This h and this h will cancel out. And one of these will cancel out with the bottom one. Down so you see it a little better. So then this write it out. Now it becomes a 2 minus 2t minus h. So do you see how we can come about getting to here? Great. Great, great, great. Got it? Now, this question, did it seem difficult to you, or was it just a little bit more involved? So tell me about like your thought process, like how you perceive these types of questions. The beginning is always hard. So I'm gonna tell you that lots of the time when they give you a question, like this for example, you literally just have to do what it says. So okay. So like they gave you f of t and they said just do this function, this f of t plus h minus f of t over 8. It literally is just rewrite the equation and simplify. It doesn't get any more involved or complicated than that for these types. You're going to go into like graphing and factoring and finding inverses and all that stuff eventually, which is a little bit more involved, but a lot of the time it is just a lot of just doing exactly what it says. Word problems people have troubles with because of just kind of like understanding what it says. So like a simple example of a word problem would be like in terms that you wouldn't know yet. I sell lemonade through a lemonade stand. My profits are linear, and I sell my lemonade by $1.10 per cup. How much money do I make if I have to start with paying $10 for my mix? Like, that doesn't really make sense as a question to you, but it would make sense as a question if you start writing it out. So, lemonade. My profit is linear. So automatically, like, just by knowing the word, we know what it means by like a function or a graph, which you'll find out eventually. If if I make $1.10 per cup and it costs $10 for a startup, what's my profit? And it's literally just kind of like filling out the equation, understanding what it's asking for, what is information is given to you, all that stuff. Cost being a $10 startup, you automatically know in your mind that it cost me $10 to buy all the material. So that's like a minus, right? A minus 10. That would be like minus 10. If I make $1.10 per cup, well, I don't know how many cups it is yet, but I can say that I make $1.1 times every cup that I sell. And my profit is 1.1x minus 10. Then it would be like, how many cups do I need to sell before I make at least $10? Or $20? And then you would understand, oh, it says the profit is $20, solve for X. Those type things. This comes with time. It's a lot of logic, but it's not too bad. Okay. Now the next, like that first problem we talked about, that random domain and range, like find a function, that was a little bit difficult for someone who's new to function. Not gonna lie, I wouldn't even do that. A lot of people, I would say, what's a function with a domain of 0 to infinity and a range of 0 to. Yep, we can take a break. It's actually almost lunchtime here, so I should probably take a break too as well. So I tell you what, we'll pause, have some lunch, a little break, and come back in how long? How long should we take? Like, I don't. What's your schedule like? What do you have going on today? Okay. Yeah, an hour and 15. I'll be back on. That's like a good time. Okay. In that same time, let me know if there's anything else. Yeah, no worries. When you come back, you can let me know like what other topics you want to cover as well, in case there was something you've seen that you want to like double check on. Let me know. Till then, we're gonna pause for now, and we'll come back in an hour and a half, hour and 15. I'm glad that we got it working though. Like, holy cow. I've never had issues like that with someone. Perfect. I'll see you in a bit.